Isn't this fantastic? All this expertise and all this content is being generated by a public community where everybody can just participate, right? This is all community effort. It's the stuff that we're doing in the community, and with this I'll kick off the last session as well, which is focused on immersion requirements. I am personally the workstream lead for that as well, as being the project lead for immersion. We recently did a call for new workstream leads for 2 vacant positions. One of these positions has been the co-leadership alongside with me. We selected a new lead for that, which is Rick Margaretson. He's now working with Rousseau Group as their CTO. In the future calls, he will be co-leading a lot of these calls, and he will be leading some of the focus group efforts that we have ahead of us. Start with a bit of an introduction. There is a reason for having immersion requirements. The immersion requirements are covering, are focused on the generation and maintenance of quantifiable requirements and required disclosures of immersion technologies. What does it mean? We have explicit things that we want to see from immersion technology. It's not really a specification. We don't predefine what immersion technology has to look like, but we do want to set a couple of very minimum baseline boundaries to ensure that we only have viable products in the ecosystem. Therefore, the requirements documents are a mix of very explicit requirements, but also contains white paper-like content, which explains some of the best practices or elaborates on the reasons why or how you could look at certain elements, right? Within Open Compute, we're using the requirements to ensure that anything that is being put on the marketplace, the OCP marketplace, or anything that needs to get, or that anyone who desires to get any kind of qualification for OCP recognition for their products, we want them to go through an assessment to make sure that their immersion-related products are in compliance with this requirements document. And I'll be going through the explicit requirements as well, right? So just bear with me with that. Because we just want to have that minimum level of quality, right? And we want to ensure that when technologies are positioned and marketed, that it's done with accurate information. This is one of the, remember in my opening session this morning, what I referred to as well, we can't have too many misconceptions or conflicting information in the industry. That's why we require very specific, quantified disclosures of very specific aspects of a technology. It's not the only purpose of this document. One of the other things that we have in the industry, which is one of the hurdles for the adoption of immersion, is that there is no regulated atmosphere around immersion technology. Why is that? Because immersion technology as a definition within regulations and standards didn't really exist. It's starting to be created right now, but these are things that take a long time to go through all the motions with IEC, with UL, with other certification bodies in other parts of the world. So if you need to, if you as a customer want to have something that is CE certified or UL certified, to get a certificate, these organizations that do assessments don't really know what to do with it. And so these kind of practices needs to be built. UL has started with this already. We are liaising directly with IEC to facilitate the standards, and the immersion requirements document is at the foundation of standards that we want to facilitate in the industry worldwide. And so even though the use within OCP itself is still fairly limited, it is what matters is that this document exists and is being used as a foundational document for all these global certification standards. The document establishes common terminology. We want to make sure that everybody refers to the same things with the same type of references, right? If we call something an immersion fluid, it's just what it is. That's an immersion fluid. It's defined somewhere in the document. The fact that we're working with open bath, enclosed chassis, or clamshell, those terms are all identified and covered within this requirements document. As I mentioned, the qualification is required for any kind of access within Open Compute. Within the workstream, we are currently focused on, or nearly done with the wrapping up of a first amendment to the second revision of the document. So the first version of this document was released a couple of years ago. 1.5 years ago, we released a complete overhaul to that requirements document. Right now, there's a couple of elements within that same document which we're updating and changing and amending. So there's not going to be a whole new revision. It's just going to be an amended version of that revision 2. A couple of things that we're focused on is thermal loss to air definition, which is something I'll be explaining as well, but it's necessary for facilities to plan for an impact on air cooling. Hey, but we're talking about immersion cooling. What do you mean air cooling? It's liquid cooling, right? Yeah, but a tank warms up and rejects heat also towards the environment. So you still have an impact on an existing air cooling infrastructure, right? What is that impact? How does that relate to the liquid cooling performance? That is something that needs to be quantified and needs to be addressed. We finalized the new fluid disclosure requirements based on also the contribution by Intel. And in the upcoming year, we're going to continue our focus on auto-ignition temperature and flashpoint evaluations. And we'll also be more focused on further alignment with IEC. So I want to take you through some of the elements within the Immersion Requirements document. Within the document, we distinguish between 3 types of requirements. There we're dealing with specification requirements, and these are requirements that need to be embedded in an immersion product. In this case, we're talking about the manufacturer of an immersion solution, right? Whether it's a tank or a rack-based solution, single-phase, two-phase, open bath, enclosed chassis, doesn't matter. These are the explicit requirements that need to be taken into account that you can check off. Optional requirements. There's a couple of requirements that we defined as optional. All right, so why would you do it? Yeah, because these optional requirements can be met to enable a specific type of recognition for example, a thermal optimized solution or a high safety or high availability solution. I'll get into that in a couple of slides from here. Customer requirements are requirements that should be implemented by owners, operators, in general, end users, whoever is going to be responsible for owning or operating a solution. You need to be some kind of behavioral codes or some types of implementation measures need to be in place for that. And that is something, obviously, a hypothetical customer cannot provide the sign-off, but a vendor will need to show that they're presenting these materials in their documentation, that they have taken into account specific measures that an end user must take to prevent, for example, undesired release of fluids into an environment. Right? The second chapter of the document covers all the technology definitions. Some of them we've already covered earlier this morning. Just gonna put the highlights in. Technology cooling system is something that we've taken directly from ASHRAE, right? Contrary to a facility water system, which is the circulation system in the backbone. Single phase versus two phase is explained, and the enclosed chassis, and so forth. Chapter 3 is where we're starting to get into more specific content. This is about quality and safety requirements, where we require any kind of technology to be compliant with existing regulations in, for example, related to regions, right? But also address some very specific items regarding mechanical safety. You must have some emergency procedures in place. A technology must be usable by somebody who may not be an expert, a material expert of what immersion is. Right? Opening a lid or accessing a server should not require a ridiculous amount of training or specialties regarding fluid maintenance, you name it. Electrical safety, the things that we're all used to, an electrical cabinet with exposed connectors or things like that, that shouldn't be part of a solution. You need to be able to facilitate and also argue for how you are making sure that the electrical system is safe for interfacing and using by end users. Things like fluid and gas containment are part of that. And then we get into the quality and safety requirements regarding liquid management, both on the facility and fluid side. Right? I'm not going to name all the very specific requirements. Chapter 4 is where we've already covered quite a few materials this morning with the fluid spec. The fluid spec, as you may recall, refers to very explicit values for a lot of the fluid properties. The properties themselves need to be disclosed. Even if you don't meet the fluid spec, it may not be a problem, it just doesn't meet the Intel fluid spec. Doesn't mean your product is not suitable in the market. This is a set, this contains all the fluid disclosures, properties that must be disclosed by a fluid manufacturer or an immersion vendor if they combine their product with very specific fluids. Here's an example of that list, and it's a bit small. It wasn't meant to show every little detail in there, but you may recognize a lot of the references that we already covered this morning. So loss tangent, dielectric constant, but also things like viscosity, vapor pressure, but also things like exposure-related disclosures. So STOT, what is the safety, the human safety related to a specific type of fluid? The things that we've updated in here compared to the previous release are, first of all, we do no longer allow an estimation for a dielectric strength. So the oil and gas industry is used to a different type of measurement for dielectric strength than what we are requiring for the purpose of immersing IT equipment. That relates to a gap size for dielectric strength, right? When you measure the dielectric strength, oil and gas industry is used to 2.5 millimeters distance. We need that to be 1 millimeter. Why is that? Because electronics design currently uses a dielectric strength of air, which is based on a value per millimeter. We want to make sure that there's not going to be any confusion working with different kind of measurements between electronics and oil and gas. Therefore, since these measurements are done for the fluids, we want to make sure that when these measurements are done, that these measurements are actually done with that 1 millimeter gap. Things like flashpoint. Apparently, we used to have the reference Cleveland open cup. That's now going to be Cleveland closed cup. There's been a lot of discussions. Again, I'm not a chemist. Apparently, there is a big difference in the use and application of this. It's just that is one of the minor changes. One of the bigger changes is that we now require very specific measurements on a whole range of temperatures, between 20 and 70 degrees, intervals of 10 degrees, for maximum moisture content, specific heat, thermal conductivity, density, kinematic viscosity, and vapor pressure. because these values matter and feed back into figure of merit, which Peter Cooper has been able to explain to you. Right? These figure of merit calculations are essential to assess the performance potential with certain fluids. Now, we require the disclosures of the values that are needed for calculating those figures of merit. We've now reduced the requirement for viscosity to only disclose the kinematic viscosity. Why is that? Because the dynamic viscosity can be calculated. We've added boiling point, especially to account for two-phase fluids, addition of latent heat or vaporization, surface tension and gas phase density, all for the two-phase materials, which are all, again, looping back into figure of merit calculations. And we've added a whole bunch of minor corrections. We do have a few explicit values as absolute minimums. So remember that sheet that we saw for the fluid specification, which contains a whole lot of values. We also have a few explicit values, but these values are not related to performance of IT equipment, but pure bare minimum requirements for fluids that they must meet before you should consider using a fluid in the first place. Dielectric strength, 6 kilovolts per millimeter, should be a dielectric strength over the lifetime of a fluid. If you get below that, it's just not suitable for electronics, for protecting electronics, right? So we want to make sure that any fluid just meets that. If you can't meet it, you shouldn't be an immersion fluid, right? The same thing for flash point and auto ignition point. We are still using the numbers that are provided by IEC for insulating fluids. Why is that? Because that is something that any fluid must meet in the industry. Are these values correct? Probably not. But we can't lower them, because if you want to have something that is certified, UL certified or CE certified, you have to meet these requirements. These points, the flash point and auto ignition point, are topics that we're going to be aligning with IEC on. We're going to put a lot of effort in that alignment and providing a case and doing studies in, okay, what are safe references for these data points? Then we get to fluid quality management. There are references there's a bit of white paper content as well on what kind of things you need to consider for maintaining the quality of the fluid over time. Now, optional requirements. This is where we're going to see them for the first time. We also have some that we call feature classifications. Right, there's many immersion type products out there. They all have different capabilities. Some of the more extensive capabilities or high safety aspects of certain solutions, we want to be able to recognize those, right? Because some technologies have put more effort, some manufacturers have put more effort in certain type of functionality in their technology than others. And it just makes sense to allow those companies to justify that by also allowing them to position those things. So we start off with a set of absolute minimum requirements. And these requirements are the bare minimum. You need to have the ability to measure the temperatures in your dielectric fluid. Highest and lowest points, at least so you know what the delta, what the temperature difference is between the hottest and the coolest dielectric fluid. You need to have, at the very least, some kind of an overheat protection. So if certain temperatures are used, that power is cut off, right? For obvious reasons, because IT equipment generates heat. It needs to be protected. Pump status and redfish compliance is something, especially the redfish compliance, is something that is particularly relevant within Open Compute, because within Open Compute, everything is based on redfish as a management approach. We've added to the minimum requirements, or we are adding, I should say, dielectric volume, content, and level detection. or level detection, I should say. So there is a way to monitor how much fluid is in a solution, but also the dielectric fluid or water leakage detection. If there is a leak, it should be detected. That used to be a high safety requirement, an optional one. The current proposal is to move it into the minimum requirements and to make it mandatory for any kind of technology. Then we have the optional requirements for thermal optimized solutions. What does a thermal optimized solution mean? It means that you have a means to monitor the power that goes into a solution, that there is a facility water system related interface for thermal monitoring, so that you know what the temperature of the facility coolant is that comes into the tank and comes out of a solution. That you can also monitor the flow rate, and that you can control the flow rate to manipulate the delta T that comes over across a solution for the facility water system. Or that you have a variable pump for the technology cooling circuit. A high safety classification means that you comply with everything that is in thermal optimized, so you must also be thermal optimized. High safety comes on top of that with an additional requirement for full reporting and continuous logging of all sensors. And you should have controls to shut off valves and pumps and also electrical inputs. There must be a fault reporting method, so the system must be able to send out fault reports or alerts, and also must have some automatic safety responses, right? So if this happens in combination with this, the system will independently perform an action aimed at protecting the IT equipment or something else that might be relevant around it, right? This section used to include the volume and leak detection. This is now moved to the minimum requirements. Then we have the high availability classification, which also includes high safety and thermal optimized. So that is a given that must be met. On top of that, you also must have a way of implementing concurrent maintainability on all components that make up, all the critical components that make up the immersion solution, right? Without IT equipment downtime, which means that if there's a heat exchanger or a CDU or a pump, you must be able to exchange those components without affecting the continuity of the IT equipment. It effectively means also you must have a dual power setup, redundant power capability with an N1, N+1 or 2N cooling capability. Right? Getting towards the general standards is where we are implementing certain terminology and prescribing how you can define or how certain parameters, certain specification items need to be disclosed. One of the things is we require SI units. Right? There's not many Americans in this room now. In the US, this sometimes results in a couple of frowning audience members. But across the world, especially in the data center field, it is important to have a similar frame of reference. So SI units are required across all the cooling environments projects. The general standards include things like definitions for compute density, and solution footprint to give an impression of, hey, all right, what kind of density can you achieve with a certain solution? But while also including things like, okay, how much space do you need to access a unit or to access certain parts of the system that you may need to access from maintenance, right? So what does it do for your service area in your white space or in your data hall? And there are various other references to it as well. One of the last things I just want to get into is the thermal loss factor. So as I mentioned in the beginning, thermal loss to the environment is an important thing, especially when you're looking at data center facility design. Now, I had a very good chat with John Gross the other day, who happens to sit here as well. We also pointed out that in various industry bodies, there's made a differentiation between radiated heat and convection, and heat that is heat by convection. It's important to distinguish between those. As a starting point when it comes to immersion technology, we've decided to just at least have something to begin with, which outlines how much energy is not going to be captured by the water circuit, but it's just lost to the environment, irrespective of whether it's radiation heat or convected heat. Right? There's a proposal that is still being evaluated which only applies to single-phase immersion cooling. And I'm just realizing now that that this text is already outdated. This is something which we're currently shaping as we speak. The last modification has been done 1.5 weeks ago, where we had to take out the two-phase elements of this. So this is work in progress. If you have views on this, we welcome your input in the Immersion Requirements calls. We're trying to wrap up this material in the next 1 or 2 months. Last thing I just want to point out here is that from now on, we require any solution to make a BIM model available. Now, BIM models are lightweight, 3D models of a technology, of a solution. And when I say lightweight, I'm talking about just a couple of kilobytes, right? Which provides the geometric data of a solution, a basic shape, but most importantly, the connection points for where the water circuit needs to be attached, where the power connection is, or any kind of other interface, what the parameters are, which need to remain free when you install a system, or how much space you need in the front of the back of a system. That kind of stuff can be disclosed in a simplified BIM model, which can be used by any designer, any facility designer, to prepare a facility for immersion technology. And obviously, it should include parameters like, hey, what kind of voltage is needed, what kind of flow rates, any kind of information that might be relevant for a facility designer must be disclosed. Currently in progress in the Advanced Cooling Facilities group is an effort to define a very simple, very basic requirement for BIM models, or specification for BIM models, which can be used to generate BIM models. As soon as that is out, we can also include that reference, so this requirement is directly connected to that. For the rest, we're out of time, but the rest has pretty much remained unchanged. If you have a technology and you want to qualify, you want to get some kind of an OCP logo, whether it's OCP accepted or inspired, or you want to position your products on the OCP marketplace, you're going to have to go through a qualification. What does it look like? First step is to send an email to the project leads for immersion. Right? We'll take care of you from that point onward. You're going to have a checklist where you can put a check behind every requirement that there is to show that you're compliant. So it's pretty much self-certification. You're going to be asked to present your qualification to the community with an outline of why and how you comply with the requirements that are set out. We do have a panel approach to that as well, which we would want you to go through, which includes the authors of the requirements documents, where we can apply a peer review, ask certain questions, where you can also ask questions about, hey, am I compliant with this the way that it was intended? Are there any improvements that need to be made? And out of that comes an approval a decline, a rejection, or a provisional approval with a couple of follow-up items that you might need to look at before achieving your logo, right? So it is accessible for everyone, and it's also community-driven. It's by peer review. It's a community effort again. With that, I want to conclude the immersion sessions for this morning. The requirements calls are once every month. The detailed schedule is on the wiki page, which is the top link. If you want to join the mailing list and receive the invitations, you can scan the bottom one. And for now, also on behalf of all the workstream leads, especially the ones that have not been able to be here today, I would like to express my gratitude for you being here. And I also want to thank all the workstream leads for their intense work on preparing all the materials for today. Compliments, the materials were excellent and fantastic, and I hope that you've all enjoyed this morning with us. There is, in the lunch area, a couple of tables which are marked for cooling environments. If you want to engage more with the project and workstream leads, that's the area where you can find us. And for now, I wish you a fantastic rest of the day. And I'll be around the whole afternoon if you have any further questions. Thank you.